Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will study the convergence of the series on that which is n going from 1 to infinity of n to the power of n divided by n factorial. And the technique that I will be using is the ratio test. Let me give you a small hint about the ratio test. The ratio test, you take the series and you call it an. So my an would be equal n to the power n divided by n factorial, and then the ratio test is the absolute value of an plus 1 divided by an, and if the absolute value of that of the limit when n goes to infinity, if it is greater than 1, we say that the series diverge. If it is less than 1, we say it converge, and if it is equal to 1, it is inconclusive. So that means that I have to use another test to see if it converge or diverge. Here I know an, which is n to the power of n divided by n factorial. Let's calculate an plus 1. So all what you have to do is replace n by n plus 1. So my n become n plus 1 to the power of n plus 1 divided by n plus 1 factorial. And we said the ratio test is the absolute value. But if you look here, my n is going from 1 to infinity. My n is going from 1 to plus infinity. So it's always positive. So I don't care about the absolute value anymore because I know it's always positive. So now I have to study the limit when n goes to infinity of an plus 1 divided by an. And let's replace each term by its value. I know that my an is here and my an plus 1 is there. So it is equal to the limit when n goes to infinity of n plus 1 to the power of n plus 1 divided by n plus 1 factorial divided by an, which is n to the power of n divided by n factorial. I wrote the divided like this because I will make it multiplication and I have to flip the second fraction. So I'm studying the limit when n goes to infinity of, well, an plus 1 to the power n plus 1 to the power n plus 1, I can write it n plus 1 to the power of 1 multiplied by n plus 1 to the power of n. And n plus 1 factorial, I know 7 factorial, for example, it's equal 7 times 6 times 5 times 4. So 7 factorial, I can write it equal to 7 times 6 factorial. So this will be equal to n plus 1 times n factorial multiplied by n factorial divided by n to the power of n. So I changed my division to multiplication, but I had to flip the second fraction. So now I can see, I can simplify by n plus 1 and n plus 1 here, and the n factorial by n factorial. So my limit that I will study is when n goes to infinity, n plus 1 to the power of n divided by n to the power of n, which is equal to the limit when n goes to infinity of n plus 1 divided by n to the power of n. So if this limit here, if it is less than 1, we say that it converges. If it is greater than 1, it diverges. And if it is equal to 1, it's inconclusive. So here I want to study if it is less, greater, or equal to 1. So when n goes to infinity, I can write it like this. Limit when n goes to infinity, well, n divided by n is 1 plus 1 divided by n to the power of n. When n goes to infinity, I would have this is equal to 0, and I will end up 1 to the power of infinity, which is indeterminate. So I have to find another way to study that limit. The other way, I would say let y equal 1 plus 1 divided by n to the power of n. So here I can say ln of y is equal to ln of 1 plus 1 divided by n to the power of n, and using the logarithmic rule, my ln of y is equal n ln of 1 plus 1 divided by n. So because my y is equal to this, and now I have ln of y, I'm gonna study the limit when n goes to infinity of ln of y, which is equal to the limit when n goes to infinity of n ln of 1 plus 1 divided by n. Let's write it in a more clear way. 1 plus 1 divided by n. Yeah, I will highlight this and I will add it to the end. So I will work on the right hand side of my equality here, and then I will add the limit of ln of y when n goes to infinity. So here, if I replace my n by infinity, I would have infinity. 1 divided by infinity is 0, ln of 1 is 0, so infinity times 0 is indeterminate 2. So I have to rewrite my right hand side of my equality in a way that I can calculate it. So I can write it like limit when n goes to infinity of ln 1 plus 1 divided by n, and instead of writing the n here, I can divide it by 1 divided by n. Yeah? And again, this would go to 0, ln of 1 is equal to 0, and this would go to 0. I have 0 over 0 indeterminate, and here I can apply the hospital rule. The hospital rule is the derivative of the numerator divided by the derivative of the denominator, and I know the derivative of ln of 1 plus 1 divided by n is equal 1. The derivative of ln is x is 1 divided by x, divided by 1 plus 1 divided by n, multiplied by 1 divided by n prime, multiplied by the derivative of 1 divided by n, and the derivative of the denominator is 1 divided by n prime. But 1 divided by n, the derivative of 1 divided by n, I can write it n minus 1, like this. It becomes minus n to the power minus 2, which is minus 1 divided by n squared. So this, I can replace 1 divided by n prime, I can divide it by minus 1 divided by n squared. So I have to study the limit when n goes to infinity of 1 divided by 1 plus 1 divided by n divided by minus 1 divided by n squared multiplied by minus 1 divided by n squared. So this and this, I can simplify it, and I would have this when n goes to 0 to infinity, this would go to 0, and I would have the limit when n goes to infinity is equal to 1. Now I go back and we said we're gonna apply this. So now I know my ln of y is equal to 1. So my y is equal to the e to the power of 1. But I know that my y here, it's equal to this. So, and this, whatever I said, this equal to this. So 1 plus 1 over n to the power of n is the ratio, my ratio test. So my ratio test is equal to e. So my ratio test, which is an plus 1 divided by an, is equal to e, and e is equal 2.7 something. So it is greater than 1. My ratio test is greater than 1. That means that my series sum of n equal 1 to infinity of n to the power of n n to the power of n divided by n factorial diverge, because my ratio test is greater than 1. If you like my video, please subscribe to my channel. That would help me tremendously, and it would encourage me to do more videos like that for you. And if you push the like button, I would really appreciate it. Thank you for listening.